A significant increase in kilowatt-hours usage, such as doubling from 1 month to the next, warrants a systematic investigation to pinpoint the cause. Several potential issues could be responsible, and a methodical approach using diagnostic tools will help to isolate the problem. Firstly, consider that a sustained current draw of approximately 5 to 6 amps on a 230 volts circuit or 11 to 12 amps on a 120 volts circuit, operating continuously, will indeed result in a substantial increase in energy consumption. This translates to roughly 1,000 kilowatt-hours per month, which aligns with the reported increase. With these measurements in mind, the following steps can be taken. Begin by examining the electrical service panel. Visually inspect all circuit breakers for any signs of damage or overheating. Ensure that all breakers are properly seated and making good contact. Use a non-contact voltage tester to check for any stray voltage in the panel enclosure or surrounding areas, which could indicate a grounding issue. Next, use a clamp-on ammeter to measure the current on each branch circuit. Perform these measurements at different times of the day and night to capture variations in load. Pay close attention to any circuits that exhibit consistently high current draw, even when the connected appliances or devices are supposedly off. This could indicate a phantom load or a malfunctioning appliance. Now turn your attention to the electric water heater, which is a common culprit in cases of unexplained high energy usage. Firstly, inspect the water heater for any signs of physical damage, such as leaks or corrosion. Carefully examine the wiring connections to the heating elements for any loose connections or signs of overheating. Secondly, test the heating elements themselves using a multimeter. Disconnect the power to the water heater at the circuit breaker. Then, disconnect the wires from the heating elements and measure the resistance across the terminals of each element. A reading of infinity, or an open circuit, indicates a burned out element. A reading of 0, or a short circuit, indicates a shorted element. A normal reading typically falls within a range of 10 to 20 ohms, depending on the wattage of the element. Next, check for a ground fault in the water heater. With the power still disconnected, measure the resistance between each element terminal and the water heater tank. A reading of anything less than infinity indicates a ground fault, meaning that current is leaking from the element to the tank and then to ground. This is a dangerous situation and can cause the water heater to consume excessive energy. If any of these tests reveal a problem with the water heater, the faulty component should be replaced by a qualified technician. With the water heater checked, proceed to the underground feeder to the detached garage. Underground feeders are susceptible to insulation breakdown due to moisture, physical damage, or age. This can result in current leakage to the surrounding earth, leading to energy waste. To inspect the underground feeder, firstly, disconnect the power to the feeder at the main service panel. Then, perform a visual inspection of the exposed portions of the cable for any signs of damage or deterioration. Next, use a megometer, also known as a megger, to test the insulation resistance of the cable. Connect one lead of the megger to one of the conductors in the cable and the other lead to a grounding rod driven into the earth. Apply a test voltage, typically 500 volts or 1000 volts, and observe the resistance reading. A low resistance reading, typically below 1 megohm, indicates insulation breakdown and current leakage. Repeat this test for each conductor in the cable. If the insulation resistance is low, the underground feeder must be replaced. Before replacing the feeder, it is advisable to investigate the cause of the insulation breakdown to prevent recurrence. Check for any signs of water intrusion, physical damage, or improper installation. When replacing the feeder, use a cable that is rated for direct burial and is suitable for the soil conditions in the area. Ensure that the cable is buried at the proper depth and is protected from physical damage. Finally, consider other potential sources of high energy consumption. This includes inefficient appliances, lighting, and electronics. Replace old appliances with energy-efficient models that are Energy Star certified. Switch to LED lighting, which consumes significantly less energy than incandescent or fluorescent lighting. Unplug electronics when they are not in use to eliminate phantom loads. Check for air leaks around windows and doors and seal them to prevent energy loss. Insulate walls and ceilings to reduce heat loss in the winter and heat gain in the summer. If the problem persists after these steps, consider hiring a qualified electrician to perform a comprehensive energy audit of the home. An energy audit can identify hidden sources of energy waste and recommend solutions to improve energy efficiency. Be sure to verify the electrician's experience and qualifications before hiring them. Request to see copies of their licenses and insurance certificates. Also, ask for references from previous customers. By systematically investigating these potential causes, one could effectively diagnose and resolve the mystery of the high electric bill. Remember to prioritize safety and consult with qualified professionals when dealing with electrical systems. It is also a good idea to contact the local utility company to discuss any concerns about high energy usage. The utility company may be able to provide additional insights or assistance in identifying the cause of the problem. They may also offer rebates or incentives for energy-efficient upgrades. Furthermore, the utility company can verify that the meter is functioning properly and accurately measuring energy consumption. While new meters are generally reliable, it is still possible for a meter to malfunction. In some cases, high energy usage may be due to a faulty meter that is over-reporting consumption. If there is a strong suspicion that the meter is inaccurate, request that the utility company test the meter. The utility company will typically remove the meter and test it in a laboratory to determine its accuracy. If the meter is found to be faulty, the utility company will replace it and may issue a credit for any overcharges. In addition to the technical aspects of diagnosing high energy usage, it is also important to consider the occupant's lifestyle and habits. Sometimes changes in energy consumption patterns can be attributed to changes in the way the home is used. For example, if there are more people living in the home, or if someone is working from home, energy consumption may increase. Similarly, if there are new appliances or devices in the home, such as a hot tub or a home theater system, energy consumption may increase. It is important to be aware of these factors when trying to diagnose high energy usage. Encourage the occupants to be mindful of their energy consumption habits and to take steps to conserve energy. This includes turning off lights when leaving a room, unplugging electronics when they are not in use, and using energy-efficient appliances and lighting. By working together, the homeowner and the electrician can effectively diagnose and resolve the mystery of the high electric bill. Remember that safety should always be the top priority when dealing with electrical systems. If the homeowner is not comfortable working with electricity, they should hire a qualified electrician to perform the diagnosis and repairs. When measuring current with a clamp-on ammeter, it's crucial to understand how to properly interpret the readings. A clamp-on ammeter measures the current flowing through a conductor without having to make direct contact with the conductor. This is a safe and convenient way to measure current, but it's important to use the ammeter correctly to obtain accurate readings. Firstly, ensure that the ammeter is properly calibrated and set to the correct range. If the range is too low, the ammeter may overload and give an inaccurate reading. If the range is too high, the ammeter may not be sensitive enough to detect small currents. Secondly, clamp the ammeter around only one conductor at a time. If the ammeter is clamped around multiple conductors, the readings will be inaccurate because the magnetic fields from the conductors will cancel each other out. Thirdly, position the ammeter so that it is perpendicular to the conductor. This will ensure that the magnetic field is properly aligned with the ammeter sensor. Fourthly, take multiple readings at different points along the conductor to ensure that the current is consistent. If the current varies significantly, there may be a problem with the circuit. When measuring current on a multi-wire branch circuit, it's important to measure each conductor separately. A multi-wire branch circuit consists of two or more ungrounded conductors that share a common neutral conductor. The current on the neutral conductor is the difference between the currents on the ungrounded conductors. If the currents on the ungrounded conductors are equal, the current on the neutral conductor will be zero. However, if the currents on the ungrounded conductors are unequal, the current on the neutral conductor will be the difference between the two currents. In some cases, a high current on the neutral conductor can indicate a problem with the circuit. For example, if there is a ground fault on one of the ungrounded conductors, the current will flow back to the source through the neutral conductor, resulting in a high neutral current. Therefore, it's important to measure the current on each conductor of a multi-wire branch circuit to ensure that the circuit is functioning properly. Another important consideration is the type of load being measured. Resistive loads, such as heaters and incandescent lights, draw a constant current. Inductive loads, such as motors and transformers, draw a fluctuating current that varies with the voltage. Electronic loads, such as computers and televisions, draw a complex current waveform that contains harmonics. The type of load can affect the accuracy of the ammeter reading. Some ammeters are designed to measure true root mean square current, which is the effective value of the current waveform. True root mean square ammeters provide more accurate readings for non-sinusoidal current waveforms. When measuring current on a circuit with electronic loads, it's important to use a true root mean square ammeter to obtain accurate readings. Also keep in mind, when inspecting the electrical panel, it is important to identify the correct breaker associated with each circuit under investigation. A detailed circuit directory should be present on the inside of the panel door. If the directory is missing or inaccurate, take the time to create a new one, clearly labeling each breaker with the corresponding circuit and the devices it serves. This will not only aid in the troubleshooting process but also be valuable for future maintenance and repairs. Furthermore, always exercise caution when working inside the electrical panel. Wear safety glasses and insulated gloves to protect against electric shock. Use insulated tools and avoid touching any exposed wires or terminals. If unsure about any aspect of working with the electrical panel, consult a qualified electrician. In addition to checking for high current draw on individual circuits, also consider the overall load on the electrical service. The service entrance conductors and the main breaker are sized to handle a certain amount of current. If the total load on the service exceeds this capacity, the main breaker may trip, or the service entrance conductors may overheat. To determine the total load on the service, measure the current on each of the service entrance conductors using a clamp-on ammeter. Add up the currents on all the conductors to get the total current. Compare this to the rating of the service entrance conductors and the main breaker. If the total current exceeds the rating of the service entrance conductors or the main breaker, the service may be overloaded. An overloaded electrical service can be a fire hazard and should be addressed immediately. The solution may involve upgrading the service entrance conductors or the main breaker to a higher capacity. It is also a good idea to identify and reduce the loads on the service to prevent overloading in the future. Remember that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with electrical codes and safety practices.